I got cut off in the previous recording, so now the number of recordings on Blackboard will be 3. Let's carry on. We discussed unordered files. So on the other hand, ordered files from the name save and store records in order or in sequential. So they called sequential files. We can physically order the records of a file on a disk based on the values of one of the fields called the ordering field. So we know already that the file is the relation on the table, and it consists of multiple columns and attributes. So if you take any of the columns, let's say the address, and you arrange or you sort the records that you have based on the address, so the address called ordering field. So field now referred to the column, and it's called ordering because we use it in order to order these records into the file. If the ordering file or the ordering field is also a key field, and this is important. So if you choose the ordering based on attribute that is unique, such as SSN, that's going to be called the SSN, in this case, key field, because it's unique and it guarantees that the values of a record won't be repeated. Okay, so that's the key field. At the same time, it's ordering key. A binary search, we know if we, one of the things that we have to make sure about in order to do the binary search, they must be in order. So in this case, we can apply binary search and records in order to find the specific record. And I told you about the main goal for us. It's to minimize the number of accessing blocks. I don't want to access all the blocks in order to find one record. Getting or grabbing or fetching the block from the storage and put it to the memory, that consumes time and power. So what we want to do is to minimize the number of accessing blocks. And here comes the beneficial of binary search. So the average is going to be log of base 2, and I'll show you how we calculate that in an example. So it's improvement over linear search, which we done in the previous method or in the previous unordered files. Reading the records in order of the ordering field is quite efficient. So here is an example of a file. It's an employee file. You can see it written at the bottom of the figure. We can see a couple of records. They are huge, and we can see also different blocks. So we already know if we have different records or we have huge number of records based on the size of each record, and they are different, it can be fixed as well, but this is not the topic. So we already seen in the introduction that based on the size of the block and the size of each record, they will be distributed. So you can see, for example, a number of records held by block number 1, a number of records as well are held by block number 2, and etc. till we reach to the last block in the storage for that file. So all of them in one file, but they are saved in different blocks. That depends again on the sizes of blocks and records. We can see them ordered alphabetically from A to Z, and they are divided into blocks. What else we can see? The ordering is the name, so it's key field or ordering field, unless it's distinct or unique. So if the name is not going to be repeated, the first and last name is not going to be repeated again and again, we can call it key field. Okay, so now in case, let me just put it in this way so I can draw without any problems. I said we will use binary search to find the block or to find the record in a block. Okay, so for example, if I'm looking for Ellen, or let's say Wong James, I need to reach to that block, right? I need to reach first to the block, and then I'll find Wong James among these employees in that block. And because they are ordered, now I can use the binary search. I have the algorithm for it. I just got it from the book. So you can go to the book 16.1 algorithm. You will find it there. And you can see here's the algorithm of it. So basically you always divide until you find the block that you're looking for. So because we already know the block are in order, so we're just going to check, is DW, or let's assume that this is the middle of the block, okay? And we will check, okay, is employees in the block 4 starts with W, which is Wong? No, then all above, because they all A is going to be, will be deleted, and then we will choose the remaining from the bottom. So again, we will choose here, this is, let's assume it's going to be the middle, and we will see if it is starts with A, if not, this is not the block, and we will remove all the blocks before, and we will consider the block at the bottom till we reach to the block that we're looking for, and then we will look for Wong James inside that record. So this is actually what's going to be done, and that's reduced the number of accessing blocks tremendously. Here's 3 points that audit files has some advantages over unordered files. Let's see them. First of all, reading the records in order of the ordering key values become extremely efficient because no sorting is required. So whenever you want your data to be already sorted, so in order files, they will be already sorted for you. No need to sort them again and again like in unordered files. Another point that is also useful, finding the next record from the current one in order of the ordering key usually requires no additional block access. For example, if you're looking for an employee that his SSN, let's say 5, and if you find the block for, let's say 3, let me just draw it for you, that will be easier than talking. Just let me start a new page. And I have this file which consists of employees. The first employee, let's say we are ordering them using SSN, so SSN is unique, so it is key field, and the first employee is 1, the other is 10 or 2, sorry, it might be 10 here. After 10 we might have 15, so they are in order. So for sure, if I'm looking for employee number 15, and let's assume these 2 in block number 1 and these 2 in block number 2. So if I'm already in block number 2 and I'm looking for employee number 15, and I know that 10 is in block number 2, so it's easy for me to find it in the same block. I don't need, like in the previous example when we are using unordered, so the second one is going to be in any block. It's not mandatory to be in the same block because they are in order, if that makes sense. So this is what the second point means. No need to get or no need to access another block if we are looking for just the second record. They will be most likely in the same block, unless, and this is might be rare. Here, for example, if you're looking for, let's say, let me get another one. Yeah, Wong James. Okay, so you know that the one before Wong James, or let's take, sorry, right Pam. Okay, right Pam here. So I'm sure that right Pam is in block number N, which can be any block. So if I want to look for the one after him, for sure it will be in the same block because they both start with W. That will be Wade Charles. But what if I'm in block N-1 and I'm pointing towards Manny and I want to get the one after him because Woods Manny is the last record in the block. So I have to access the second block in order to reach to right Pam, right? So this is the case when you need to access the second block in case the record was the last one in the block. Using search condition based on the value of an ordering key field results in a faster access when binary search technique is used. Inserting records are expensive operations because the record must be remain physically ordered, and this is one of the drawbacks of ordered because you have to make them always in sequential or always in order. So for example, in the example that I'm having here, if I want to add an employee with the record or with the SSN 7, so I have to make a space for him. I have to both shift 10 and 15 to be under there. So for example, 10 will be here, 15 will be there, and 7 then will be here. So that shifting is going to be time consuming and takes a lot of power. So find its correct position in the field based on its ordering field value, make space in the file to insert the record in that position. Disadvantage, time consuming, as I said, for a large file, half of the file or half the file blocks must be read and rewritten after records are moved to make space for the new record. Here, what I said about the comparison between the heap or unordered files and ordered files. So we know that if it is an ordered, we just search. In order, if you want to search, we will use the linear search. So we have to pass through all the records one by one. And in average, this is the formula that will be used. So an average to reach, for example, to that record, most likely will be a block in the middle. So for example, if you're looking for, it's not ordered like this, and I'm looking for the employee number 4, which is in orange here, I need most likely to pass through the half of the blocks to reach it. So I'll just look for block number 1, and I'll check block number 3, and then I'll find it in block number 2. In this case, it's the worst case scenario because I find it in the last block. So, but most of the time you will find it in the middle. And here's just a quick formula that we can have. For example, if you have 10 records and you are using heap or unordered files in order to arrange your records, most of the time you will find the block that hold your record in number 5, because 10 divided by 2 is going to be 5. And with the log base 2, it's going to be more or less. Do the calculation, just put log base 2 to the, and B is going to be the number of blocks with a 10. You will see it will be quite less. It comes in handy when you have a huge number of blocks, let's say 2080 or 2048, which we already done in the previous lecture. So if you have 2048, then here it will be around 1024 bytes, or sorry, 1024 accessing blocks until you find the right block. And here I believe we calculated it was about 11. Make sure of it. But see the comparison, it's quite huge. So the number of blocks you need to access is quite less, okay? The last thing that we also, I will cover in this session, it's hashed values or hashed files. So in here, we will use hashing for disk files. It's called external hashing. The file blocks are divided into m equal sized buckets, numbered bucket 0, bucket 1, bucket m-1. So let's see it in this figure, for example. So in here, I'm having my file, which is, you already know, the employees, right? And inside every packet or inside every bucket, I'll have a number of records installed or stored in it. And that's going to be based on the hash value. Okay, so we already discussed the hash value. For example, if I'm using SSN, okay, SSN, and I have a number of employees and also a number of attributes, right? All of these are attributes. And I'm using the hash, which I call it a hash key, to find the right bucket for every employee. There will be a hash function. Most of the time, hash function, it's something like this, k mod m. K here represents the key hash. And when I say, or hashing key, okay, which is here. When I say hashing key, I mean the attribute that I'm going to use in order to pass through the hash function. So for example, let's take this one here, which already explained. I will leave it for you in the second recording or the third recording, you can see that. So just here, a quick example, if we have these employees, let's consider them to be employees. And these are the SSN of them. So this is the first employee, which is 50, his SSN, the other one is 700, the other one is 76, and etc. And here I'm having the hash function, okay? SSN here are considered to be a hash key. And I'm having under that bucket, you can see it, the bucket is empty and it consists of 7 cells, right? How I fill these records or these employees in buckets, it's going to be straightforward. So basically you'll take the 50, which is the SSN of the employee, you will insert it or you will pass it to the function. And this case is going to be 50 modulus 7, that will result in 1. So 50 will be stored in cell number 1. Another employee, 700 modulus, so you will take it to the function, 700 modulus 7, that's going to be 0. And then 700 is going to be passed to record 0. Similarly with 76, that's going to be 76 modulus 7, that's going to be 6, and this will be passed to the bucket 6. So see how the hash function works with the hash key. Okay, now we understand the concept. Let's go back. So after you put each record in a bucket will take a place in a block. So a bucket will just point to the block that will be saving these records in. By the way, a bucket can hold 1, 2, 3, or amount of number of records. So it depends about how you initialize it. So a bucket can hold 10 records. For example, let's say here I'm having 1 and 4 employees. These are 2 employees. Both of them will be saved, for example, in bucket 0. And bucket 0 by itself is going to be saved in this block. Another 2 employees, let's say 10 and 3, are saved in bucket number 1. And bucket number 1 is held by this block. How this is going to be useful? This is going to speed up the way you search for record. For example, if you're looking for employee number 10 and you don't know in which block it's saved, let me take another color. I'm looking for employee number 10 and I don't know in which block this employee is saved in. So rather than do the binary search or the linear search, which is slower, I would do the hashing. How that comes? So I do the hash function, and hash function, after I pass the 10 to the hash function will let me know in which bucket this record is saved. So 10 is going to be, for example, saved in this scenario in 1. So if I know it's saved in bucket 1, I can just grab the block straightforward. No need to search for all the blocks in order to find the record. Okay, now I know it's saved for sure in that bucket, and the bucket is saved in that block. So I can reach and grab or fetch the block from the storage to the memory and look for record number 10. Especially if the bucket has, for example, 3 or 4 records, depend on the sizes of the records. So I will search inside the bucket for record number 10. This is basically how hash function works. One common hash function is, this is the hash. So we just call it h most of the time. So when you say, or when you see, sorry, h, and inside the h there is k, that means this is the key, and this is the hash function, which will give you I, and I is the number of buckets in which bucket is saved. Once common hash, I already discussed that, and search is very efficient on the hash key. Collisions occur when a new record hashes to a bucket that is already full. Here's going to be explain how it's going to be full. Again, a bucket can hold more than one record in one scenario, and in the other scenarios, it can just hold one record. It depends about the size of the bucket and the size of the block, also the size of the records. I will leave the rest for you to carry on with the third recording. All the best.